Hello and welcome to this video. This video is actually going to be the part of series of videos on Python decorators. And this video is the first one. This video covers all the prerequisite concepts that are required to understand Python decorators. And the video largely covers is variable scoping in Python. Like there are different kinds of scoping in Python like local scope, global scope, built-in scope, and non-local scope. This video is also going to cover concept on closures. And with that, we are also going to see various examples, and every example is going to cover a concept. So let's jump right in and see what are the examples and cover the concepts one by one. So as you can see, this is the first example, and this example we will be trying to understand what are local and global scope. So in this example, if you can see, this is a function add nums. It takes one parameter and it adds two numbers and returns them as a result. One of those numbers is actually the parameter that is passed as an argument here, and the other one is actually coming from the top, which is not the parameter, which is not passed as a parameter. So let me tell you before actually we can see what are local and global scope. Let me tell you what is a block in Python. So this anything written in this function, anything that you write, this becomes a block in Python. So this is the entire block that I've highlighted. This is the entire block of this function add nums. Similarly, we have if statements, if and else constructs. They have their own blocks. This is a function, it has its own block. We have for loop, it has its own block. So this is one of the examples of block, but however, we just have in this block, we just have one line, which is a return statement. Okay, now let's see what is a local scope. Actually, what is a scope? First of all, let's try to understand what is a scope. So a scope is a region in which a variable can be accessed, and you can actually that access is a valid access. So in this particular block that we are seeing, a block or a region where we can access a variable. So in this block, you see that we are accessing two variables, a, which is actually local to this function because it is passed as a parameter, or another example of a variable that you can have locally here is when you create the variable in that block. For example, if I create a variable c and name it some dummy thing, so this variable c is actually local to this function. However, a is also local to this function because it's passed as a parameter. However, b is not local because it's neither passed as a parameter or nor it is created in this block, which means b is actually coming from a global scope. So although all the variables, which means all the variables which are actually not part of any function, which are not part of any block in the code, any class, every class will have its own block. If you're not having variables created there, all those variables automatically fall in the global scope. So b is one such kind of a variable. And okay, so coming back to our example, and let's see how this works. I hope you'll be able to guess the answer of this example. I think example one. So this is pretty simple to understand. Add nums actually takes one parameter. We pass 100 here, and which means a is going to take value 100 and b is going to take value 200 because b is actually coming from the global scope. And this is a perfectly valid example of accessing b, and that's why we are able to see the results. So however, let me move to the next example and we will see what twist we have here. If you see, this example is almost similar to what we had previously, except that now b is also getting assigned in this block of code. So this function is having this block, and actually I'm creating this variable b here. Now, when we try to add these two numbers, which is a, which was passed as a parameter, b, which was, let's see from where b is read. For now, seems like because this b is not created before this result, this addition statement, seems like b should be read from the global scope. But before that, let's try to guess the output of this. You can pause the video here and try to guess the output. Okay, let me show you the output. And we get an error which says that b is local variable. But in the previous example, b was a global variable. So, and it throws the error at line result equals a plus b. So when we are reading variable a and b here in this line, but it says b is local, it seemed like b should have been read from the global scope, which is 200 up here. But the Python interpreter complains that no, b is a local. So let me tell you the concept really that is really important to understand when you are having when you are dealing with variables. So any variable which is defined in a particular scope or a block or a region, that variable is actually local to that block of code or a region. So, well, I'm using region and block of code interchangeably here, so I hope you understand that. uh, which means in this block we are defining this variable b. We are creating this variable b with a value 300, having value 300. So for Python, this variable b is actually local to this entire block. It's local to this entire block. Now, if anywhere you access b, whether before creating this or after creating this, b is going to remain local to this block. That's why that is the reason that when you're trying to access variable b is not read from the global scope, because Python considers b as local to this block. However, why do we get this error? I hope now it makes sense that we are accessing a local variable b, but we are accessing it before it was created, before it was assigned a value. And that's the reason why we are getting this unbound local error. Now, if you just simply move this statement below we created, hopefully the error should have gone by now. And yes, you should get the error, which is 300 plus 100. 100 was passed to variable a as a parameter. So that's the required output. However, if you define it before, as we saw previously, this should again result in error. Now I'm repeating. So any variable which is defined or created in a scope, in a block of code, it becomes local to that scope. It doesn't matter where you are creating that, whether you're creating at the beginning of that block of code or in the middle or in the end, it becomes local. So even if you have a variable named same variable named, which is named similarly, or exact same name of a variable, if you define it in the global scope, it won't be considered, it will be disregarded. As we saw in this case, this b was completely disregarded by Python interpreter. So this is another thing. Now I think now you would be having a fair understanding of what a local and a global scope how, what a local and a global scope is and how it works in Python. So with that, now I think we should move to the next concept, next example. And in this example, uh, let me tell you what this example does. So we have a function. We have a function which uh, is called generate names. It has a nested function here, and this function takes a name. It appends that particular new name, it takes a parameter as new name. It appends it to the names list, which was in the outer scope, and then it actually prints the entire whatever is present in that names array, names list. It actually uh, joins all those name as a string and separated with comma, and then it prints it. So this is what the entire this is what the inner function does, and the outer function returns this inner function. Well, before we actually move ahead, let's recall, or let's revisit that everything in Python is an object, like functions. So functions can be passed as a parameter. Functions can be accepted uh, as functions can be returned from a function, like from other function. It can be returned. It can be accepted as a parameter, like we can do with any other object in Python. So that's what we are doing here. This is one function which we are returning from this generate names function. Um, okay, okay. Till now, I haven't gone too much into depth, but let's try to understand. I will, if you haven't got anything so far, you will get this example, and this is a really important concept, and we are trying to build a foundation for closures. So this, when you call this function generate names, this function is going to return another function which is defined within generate names function. Now, as I said, uh, functions are treated like an object in Python, and they can be returned from an outer function. So let's call this as the uh, out, outer function, and this is actually the inner. So this outer function, generate names, returns the inner function. When you get here, what you get here is a function, which means n will be assigned with a function. Now, it's really important. If n is holding a reference to a function, which means n can be executed like any other function. And if you put uh, parenthesis after n, which means you can execute n, and which will in turn execute add and show names function, because n is holding reference to that. Because, and now if you see from line number 15 to 18, I'm passing single parameter as a string, name of Indian cricket players. So I pass Virat Kohli as one of the string parameters to this, to n, which will be taken, which will actually execute the inner function, and new name, Virat Kohli will be assigned to new name, and that will be appended to this list. But wait a second, n is having reference to this function, which was returned from an outer function. How is it possible that this inner function still has access to names variable? We are referencing that names list here. How is it having access to this? So this is what we are now shaping up to understand closures, shaping our foundation to understand closure. So closure is actually a function with an extended scope, which means, actually, let me tell you, in all the cases, closures will only appear when there is a nested function, where there are nested functions, which means functions within a function within a function. So in this case, we see that there is a function and it has a nested function. So to we can expect a concept of closure arriving here. So if this so what happens is, a closure is, I was telling its definition, closure is a function having an extended scope where it can access variables local to it and variables which are enclosed in the local scope of outer function. So in this case, whatever we return from here is actually a closure. Closure is nothing but a function. So add and show names is actually a function which has extended scope, because it can access variables which are local to this. For example, new name is actually local to this function, but it can also access variables which are local to the outer functions. So this names is actually local to this outer function. And since whatever we are returning is a closure, that closure will have access to this name. So um, when you are executing the inner function by calling n and passing this variable names, the closure will have access to the names variable. If it is not clear by now, let's see what output does it print. So I will just pass Virat Kohli. I will execute it once and I'll pass and I will execute this. So this is the example number 3. So if you see, it prints Virat Kohli from this print statement. Because names has only one name till now, because we have just passed one name, so it has printed that name only. However, let me print Rohit Sharma along, add Rohit Sharma and print it. So if you see, in the first call it printed Virat Kohli, which means names is holding only one name, which is Virat Kohli names list. Now when we pass Rohit Sharma, then the names will have Virat Kohli along with Rohit Sharma. So, and when it gets printed, it prints both the names. Similarly, if we add these two names as well, it prints all of them. For every call, it prints it. So I'm again repeating, what's happening here is we are returning a closure from this generate names function, and closure is always closure always has access to the variables which are local to that function, because closure is a function, and it has access to the local variables of the outer scope or the outer functions or the functions which are enclosing that enclosure, which means add and show names will have access to names which is local, new name which is local to this function, and along with that it will have access to the names list which is actually local to the outer scope. If you didn't understand that, I would recommend going back and understanding and seeing this entire section once again, so that you actually have a good understanding of closures. It's really important to understand closures if you are actually trying to understand, if you are actually looking forward to understand more about decorators. So I hope we are done with this example too. If you have any doubt, please leave a comment in the video, in the comment section. I will definitely respond to it. However, let me see the fourth example, sorry, my pardon. So this example is also very much similar to what we saw in example 3, except that the variable that we are accessing, okay, let me tell you, let me walk you through this example once again. So it has an outer and inner function too. This is outer function, this is inner function, and it has a compute wealth which is inner function, and wealth tracker is just outer function. So wealth tracker has this local variable total amount, and compute wealth, what it does is it takes new amount and it adds to the total amount. Every time you pass a new amount, it adds to the total amount and prints what is the total amount. So what we are doing here is, when you call this wealth tracker, we are wealth tracker returns an inner function, a reference to inner function, compute wealth, which means when you do this vt variable, when you try to execute it, it actually under the hood it will execute this function compute wealth, because this also takes an argument. So this also takes a parameter, so you have to pass one. So you are passing 100, 200, 500. So what will happen when you pass 100? Total amount was initialized with 0. So when you pass 100, total amount will be this statement. I hope you are familiar with it, but total, it is saying, it is equivalent to saying this. So total amount equals to total amount plus received amount. This statement is equivalent to this statement. So which means you are adding to the total amount 100 and storing it in total amount again and printing that. So this is fine. So let me see if that's fine or not. So Python, this is example number 4. Well, you get an error. However, you didn't get error here when you were trying to access the names variable, but you get error here. Why is that? You can try to think, pause the video here and try to think about it. Okay, so let me tell you a very little difference that these two examples are having. The name variable that was defined as a locally to the outer function was a list. Here we have total amount, which is an integer. List is actually a mutable object. So which means you can change the value of whatever is present in list. You can change its content. But total amount is actually a non-mutable object. You cannot change its content. Whenever you try to change its content, Python creates a new variable for you. For example, to demonstrate this, let me tell you, whenever you're trying to assign, so how do you create a new variable? You actually assign some value to it, so that if that variable is not created, you try to assign a value to it, so that Python creates a variable to you for variable for you. Here we see that it is integer, and every time we pass integer which was assigned a value 0, but when you pass 100 to the same variable, we are actually assigning a new new value, which is 0 plus 100. So when you are changing its content, Python is going to create a new variable for you, which means after the execution of this statement, total amount will be recreated. And if you recall the concept that if you create a variable in a block of code, that variable becomes local variable to that function or that block of code, which means total amount is no longer non-local. I mean, it's actually it's actually a local. It actually becomes local to this compute wealth. Rather, it is no longer local to this. However, um, there is a local variable in the outer wealth tracker function, but this total amount is actually local to this and not this one. So effectively, when we assign a value and we try to access it, we are actually creating a new total amount variable, and we are trying to access that. But since now whenever you access variable here, it is actually local to this, which means when you are trying to read it, that read will also happen from the local variable itself. Now, before you have created that variable, you are trying to read it. I hope I'm making sense. For example, if you didn't get that, let me tell you again. So what essentially we are doing here is total amount is equal to total amount plus received amount. So this total amount is now local to compute wealth. But okay, why is it local? Because we are trying to assign a value to it. We are trying to create it. So Python will treat that as a local variable to this function, and it will not consider the total amount which was defined in the outer scope. Since now the total amount, whatever is referenced within this function, is actually local to this, we are trying to read its value in this statement. We are also in the same statement, we are also trying to read its value, and the received amount, we are reading its value and we are adding them and assigning it to total amount. So this is the point which is going wrong. We cannot read a variable before it is created. Total amount will be created from the next line, from line number 7. Total amount will be created, but if If you're trying to read it before it was created, Python is going to throw you an unbound error. So I hope you're getting it. Okay, so now we understand that, okay, total amount is local to compute wealth, and we are trying to read its value before we have created that variable. That is the reason why we are seeing unbound local error. However, there is a way to bypass this error, and Python gives you a special keyword to bypass this error, which is non-local. However, let me show you that error is still there. It doesn't change by this statement. We will still get the error. So we are still getting the error, but let me show you what will be a solution for this. So, and well, Python says that if you are trying to access a non-local variable, which means now Python is no longer you're trying to you're sorry, total amount is no longer. Now if you introduce this statement, then total amount will be treated as a local variable from the previous or from the outer scope, which means this statement says that the total amount should not be treated as local to this function. It should be non-local to this function. Well, if you do that, you get the answer. Because we have only passed 100, total amount will only have a value 100. But let me try to increase wealth. So once you passed 100, total amount became 100. Once you passed 200, total amount will be 100 plus 200, which is 300 that we are seeing in the second line. And then when you pass 500, it will be 300 plus 500, and 800 will be printed here. I hope now you understand what is a non-local scope. So you have made this total amount as non-locals for Python to understand, okay, you don't want Python to create a new variable here. Rather, you want to access the variable which is present in the local scope of the outer function, and Python will actually do that. Okay, so this was what we wanted to know about non-local scope as well. And now I hope now you understand about closures. Uh, Next thing that we wanted to talk about is built-in scope. Built-in scope is pretty easy to understand. So any of the variables which are not present in the scopes that we have learned so far. For example, if there is a keyword which is not present, which is not defined by you in local scope and global scope or any other scope, then it is looked by Python in the built-in scope. Okay. Well, there is a very simple example to understand this. For example, if there is this print statement, there is this return statement, and then there are sorry, returns. I'm sorry, it's not statement, it's keyword. With print keyword, return keyword, def keyword. These are not defined by us. This is defined by Python. So, for example, and like that, we have so many reserved keywords. If, else, and try, except, all those keywords are present in built-in scope, which means whenever you try to access these variables, because they are not defined by us in local or global scope, Python actually finds them in the built-in scope and gives meaning to it. However it is defined in built-in scope, it will be assigned that meanings. For example, return actually returns a value from one function to the other, so that's how it works. I hope that understanding built-in scope was fairly simple, but my entire effort was to make you understand how variable scoping and closures work in Python. And with that, I'll close down the video. If you liked it, please leave a like, leave a comment, share it, and I'll see you in the next one.